On the 19th of October, astronomers noticed something unusual zooming away from the Sun. Using pan-stars, a group of telescopes that constantly scan the sky, they initially thought it might be a new comet. But after observing it for 34 days and doing some orbital calculations, they realized it was something groundbreaking, the first ever object from outside our solar system. This celestial pioneer was named Oumuamua, meaning a messenger from afar arriving fast in Hawaiian. Since its discovery, scientists worldwide have been studying Oumuamua with the best telescopes available. Today, we're diving into the latest findings, focusing on a paper by the Dutch team from Leiden Observatory known as PZ-17. This paper explores the origins of this peculiar visitor, which is still under peer review. But before we get into its origins, let's take a closer look at Oumuamua itself. Trust me, it's quite an oddball. Before we start, we want to hear from you, our audience. What do you think Oumuamua really is? Share your ideas, theories, and questions in the comments below. Like and subscribe to the Real Gaian channel for more content on the wonders of the universe. Imagine a cosmic cigar or the mysterious monolith from 2001, A Space Odyssey. Oumuamua is hundreds of meters long, yet even our most advanced telescopes can only see it as a tiny speck in the vastness of space. Despite its small appearance, it changes brightness irregularly, which suggests it's tumbling as it travels. This tumbling hints at a rough past, maybe involving a major cosmic collision. It's a bizarre sight, even in our diverse solar system. Oumuamua's unique characteristics have kept scientists on their toes. Its unusual shape and spinning motion are unlike anything we've seen before. It doesn't behave like a typical comet or asteroid from our solar system. This strange visitor has sparked curiosity and excitement, pushing us to rethink what we know about space objects and their journeys. In the coming years, we'll continue to study Oumuamua and hopefully uncover more secrets about its origin and what it tells us about the universe beyond our solar system. This interstellar messenger has opened a new chapter in our exploration of space, reminding us that the cosmos is full of surprises waiting to be discovered. Oumuamua doesn't have a tail like a comet, meaning it isn't melting from the sun's heat. This indicates it's rocky, not icy. Some might jokingly think it's an alien ship, but let's be real, it's not aliens. The weirdest thing about Oumuamua is how it moves. In our solar system, everything follows elliptical orbits because of Kepler's laws. These orbits are described by their eccentricity. An eccentricity of 0 is a perfect circle, and anything less than 1 is an ellipse, showing the object is bound by the sun's gravity. For example, Earth's orbit has an eccentricity of 0.0167, nearly circular, while Halley's comet has a stretched-out ellipse with an eccentricity of 0.967. But when objects have an eccentricity over 1, they follow hyperbolic paths, not bound to the sun. They get deflected by the sun's gravity as they pass by. Oumuamua's eccentricity is 1.2, meaning it's on a hyperbolic path, just passing through our solar system. To understand Oumuamua's speed, think about escape velocity, the speed needed to break free from gravity. When Oumuamua was closest to the sun, it was speeding at 87.7 kilometers per second, well within Mercury's orbit. The escape velocity there is a bit over 80 kilometers per second, so Oumuamua was fast enough to escape the sun's gravity and head back into interstellar space. So, where did Oumuamua come from, and why is it so fast? The PZ-17 paper looks at 3 main theories. First theory, it could be from our Kuiper belt or Oort cloud. Objects from these far-off regions, like comets, usually only gain enough speed to return to where they started, but Oumuamua might have gotten an extra push from an unknown planet. To check this, PZ-17 did computer simulations to see how often such pushes could send objects near Earth at such high speeds. They found this idea unlikely. The simplest explanation for Oumuamua's speed is that it came from outside our solar system, picking up speed as it traveled through interstellar space. The second theory is that Oumuamua was thrown out of a nearby star system and ended up coming our way. PZ-17 ran more computer models to trace Oumuamua's path and studied 3,700 stars within 100 light-years of the Sun. They found that Oumuamua passed through the Oort cloud of a star named Tai-C 4742102701 about 1.3 million years ago. However, Oumuamua was moving over 100 kilometers per second, faster than the escape velocity from that star, suggesting it was just passing through, not originating there. And no, it's not aliens throwing rocks at us. The third theory is that Oumuamua has been wandering through space for a very long time. It could be part of a huge collection of debris floating in interstellar space. This theory makes sense because during planet formation, lots of material, including some planets, get ejected from their systems. With countless stars out there, many asteroid-like objects should be drifting around in space. As our Sun moves through the galaxy, it sometimes crosses paths with this space debris. PZ-17 believes this is the most likely origin of Oumuamua. They even coined a term for such objects, lonely rock or solar lapis, with a Klingon translation, Mob Nag. Using the discovery of this one interstellar object and the space covered by pan-stars, PZ-17 estimated the number of similar objects around us. They calculated that for pan-stars to have detected this single object in 5 years, there must be about 700 trillion such objects per cubic parsec in our solar neighborhood. This density is higher than that of comet-like objects in the Oort cloud. Based on these calculations, PZ-17 predicts that between 2 and 12 interstellar objects should pass through our solar system inside Earth's orbit each year. We've only spotted one so far because most don't come close enough for pan-stars to detect. Oumuamua came relatively close, just 18 million kilometers away. Even then, pan-stars barely caught it. Smaller or more distant objects would likely go unnoticed. The exciting news is that future telescopes will be far more sensitive. For example, the Large Synoptic Survey Telescope, currently being built in northern Chile's Andes, is set to begin operations in 2019. This telescope will scan the entire night sky every few nights, making it possible to detect fainter objects and discover many more interstellar visitors like Oumuamua. The LSST will be able to see objects about 14 times fainter than what pan-stars can detect. This means we should find many more solar lapids. But what about Oumuamua? Is its journey over? In about 20,000 years, it will leave our solar system completely. However, it will become invisible to our telescopes within a month or two. Its path will take it towards the constellation Pegasus, possibly on its way to explore a new star system. Meanwhile, it joins countless other interstellar objects, pieces of planetary debris scattered across the vastness of space. Thanks for tuning in. If you missed our previous video on Oumuamua, is at the heart of an ongoing battle raging within the scientific community. Again, you can check it out by clicking on the I button. Apart from that, is Oumuamua an alien spaceship? We'll dive into that topic in an upcoming video. Would you be interested in seeing a video about how to deflect asteroids? Share your thoughts in the comments. Like and subscribe to check out other videos from the Real Guyan English channel, and make sure you ring the bell for our latest content.